the big voice. Welcome, everybody. How many people in this room know me? And I recognise a lot of people in. Yeah, okay, that's great. How many people have I offended in the last year? Everybody? Yeah, okay, that's good. So this session will be about Jetstress. So hopefully you're in the right place. There are many sessions going on that all have very similar titles at the moment, and we seem to have scheduled them all at the same time. So that was handy. This one is a session that I've been delivering for about 4 years now. Are you in the wrong session, sir? If you want to change sessions, now's a good time to do that. So this is a session I've been delivering for about 4 years now. Basically, after we made Jetstress mandatory in MCS in the UK, worldwide actually. And what we discovered when we did that is that although if at the time, if you went and spoke to field personnel and exchange professionals and asked them if they knew how to use Jetstress, a lot of hands would go up and everyone would say, yes, I am super skilled at using Jetstress and I understand it. If you then went and asked them what the numbers meant and how to do the test and what all the various bits and pieces were, you would get a huge variation in different values. And that stemmed from the fact that no one ever bothered to write down how the product worked. And that stems from the fact that the product essentially was a byproduct of Exchange Dev. So the Exchange Dev team used it to do what they needed to do, and then it got released into the public because we thought it was a kind of cool tool, but it never really had any support and it never really had any documentation with it. So this kind of session kind of started back then. This led to the field guide. So is everyone aware of the Jetstress field guide? Seen the field guide? So that's fundamentally the only documentation we have for Jetstress now. Is this thing still on? So that kind of stems from the lack of documentation that we had. We had a huge number of escalation cases of a whole mixture of things, but predominantly people misunderstanding what Jetstress is and what it does and why you should use it. And then we introduced this session into Exchange Ranger, so the Exchange Master Program. So for those that don't know, I used to teach in that before we canned it. And this session essentially is the primer that I used to deliver to the Ranger community. So this is very much the level setting intro of what the product is, why and when we should use it, what the numbers mean at the end of it, some of the current issues. So I used to go through and rev this every release that we taught and go and speak to the product group and get the current list of bugs that we've got in there and how to work around them. So strangely, there's still not clear to many people what Jetstress is for. So whereabouts we're supposed to use it. People are confused. Project managers often get confused with Jetstress. Storage teams can very, very frequently get confused because it's got the word stress in the title, right? And that's bad. Stress is bad for storage. You don't want to do that. And we need to be clear why we're doing it. So the primary reason that I started to use Jetstress was when we're trying to determine the storage performance limits. And this is predominantly, back in the day, this was around IOPS. It was purely about IOPS. Back with 2003, we were concerned because, prior to 2003, what we would see is, I remember doing Exchange 5.5 deployments, and the size and scaling was how many disks can I get in the chassis? There you go, that's how many I need. And it was RAID 5 for the databases, it was, RAID 1 for the logs, and you were done, right? And if you put users on there and it was a bit slow, you put another server in and moved the half of them across. And that was basically how you did designing and scaling. When we went to Exchange 2003, we ran into a huge number of perf issues for storage for the first real time, and it was because the demands on Exchange had gone up. So we had far more people sending far more mail messages, and so that drove the IOPS up. But also, we ended up with larger databases, more of them, and also we brought in here this dependency on SAN. We were clustering a lot, and we had SANs in place. And from an Exchange administrator perspective, it was a bit of a dark art, right? This is where, in 2002, is when most people first started to hear the word IOPS and tried to figure that out. And so Jetstress helps us understand what that is. We configure the databases, increase the thread count, and we start looking to see how many IOPS can we drive with the Exchange database engine from the storage. We also use it for validation. So when we've done a design and we think this is, we've engaged with probably storage vendors. Oh, how many storage vendors are in the room as well before I insult Orbit? Okay. So And then typically the route this takes is the Exchange team will go off and figure out the Exchange design. They'll use Ross's calc or the whatever it's called, the server role, or whatever calculator it's called now, but the storage calc essentially. And we'll provide them with capacity and IOPS limits. They'll then come back with a storage design, which tells us how many spindles and all of the stuff that they need to support that. And being lowly Exchange guys, you know what? We don't really know whether what they've come back to with us is going to function or not. We don't. We need a mechanism to validate that, because if we put real users on the platform and it doesn't meet the IOPS requirements, we know that's going to result in poor user performance, and it's very tricky to diagnose and fix that stuff once you've got live users on it. We also use it for hardware burn-in. And this is very, very useful now with JBOD. So we're seeing, and we saw a big change in this actually, where when we were on sort of 2003, 2007, most of the storage was on SAN. SAN vendors do an amazing job of essentially validating and pre-checking the spindles that you get before you get them. So the number of failures that you see in a SAN is normally fairly low. Whereas now, with Exchange 2010, and even more so with 2013, there's more JBOD stuff, and there's more cheap JBOD stuff being deployed. And we see the failure rates of those, depending on where you buy them from, but we see the failure rates of those being higher. And so being able to do some kind of burn-in test is pretty useful. So we can use Jetstress for that. Build-out test is another one. This is an area where, frequently people get really confused, right? And I remember talking to a number of large-scale customers about this. We already completed Jetstress testing in their lab, right? So we built out the storage infrastructure and we'd validated it in their test lab, and it was all good, right? We had green ticky all over the test results, and we are happy bunnies. And then they started to build out in production, and I kind of looked at the plan and said, hang on, we still need to do Jetstress testing after you've built out the infrastructure in production. And they were pushing back, saying that's going to delay it, that's going to add time to our delivery, for us to get the service live. And we've already tested this, right? It's the same thing. It's the same model, the same servers. Why do we need to repeat the testing? And it gets interesting here because there are various nuances that have caused problems in build-out. So it doesn't take a big configuration difference to cause a big impact to performance. One of my customers accidentally ordered a load of servers without the battery on the cache. So the RAID controller's there, the config is still the same. They still issued exactly the same RAID config in their automatic script, but the cache has switched off. The write cache has been disabled because there's no battery on there. As far as they're concerned, it's identical. Right? Jetstress picked that up immediately, failed miserably, but they were able to resolve it before they put live users on. And that's what the build-out tests are there for. They're there to protect you against hardware nuances. Potentially, we've seen issues. So in the service, Matt Gossage was telling me, they used to use Adaptec controllers. And Adaptec changed the microcode on the firmware for the SAS controller. And that caused them huge problems. Now, it took about, in the Jetstress test, it took about 18 hours. In the service, it took about 2 weeks for this bug to hit. And then it caused huge problems with latency. Now, the problem with that is that it became one of these intermittent problems. It depended on how busy the server was before it would kick in. It took them a long time to diagnose it. Yet as soon as they took it in the lab and Jetstress tested it, we were able to pick it up really quickly. So that's why we do those. Oh, my God. I figured out how to use PowerPoint, but anyone that's seen my Ranger presentations knows that this is kind of beyond exotic for me, having boxes and things. So normally I have a white slide with some black text. So you are very, very lucky people to see this thing. So this is the kind of standard methodology that we use in MCS. Everybody in a practice that is doing architecture and design will have some kind of variation on a theme. You kind of start off thinking about high-level stuff, and then when you get to the end, you've deployed something and you're making value from it. And this is a slide that I deliver quite often to project managers to explain to them where we should do Jetstress testing, because quite often they're confused why we would want to do Jetstress testing during the plan phase, which intrinsically for us is the design phase. This is high-level design. This is where we're trying to figure out what our Exchange solution looks like. So in here, we'd have the number of servers being deployed. We'd have the database size. This would be the solution design, fairly discrete and specific. So why would we use Jetstress during the design phase? Well, One of the reasons is that it helps us compare storage. So frequently here, I will be talking to customers that potentially have been using SAN storage, they'll have been using different types of storage essentially, and we will be having a discussion around, look, there are some new options with Exchange 2013. You could use JBOD, right? You could use RAID, you could use the same type of SAN storage that you've used before, but there are many more options available to you now than there were probably with the legacy platform that you're coming from. So taking those different types of storage and putting them into a lab environment lets you figure out how it behaves. You get a bit of hands-on to configuring that storage and looking how it operates, doing some degraded mode tests in the lab as well at this phase. So if, for example, you're looking to use RAID, maybe looking to see what the impact of a RAID rebuild is. So if you've got a RAID 5 array, for example, and you pull a spindle, the impact to latency is pretty dramatic. So it lets you observe that and observe how it gets impacted. The other thing it lets you do is if you've got a storage infrastructure that you think we are definitely going to use this type of storage, it's baked in, we're going to use it, this is a strategy, we've got a big pile of it or whatever. What it lets you do is take into the lab and actually get a precise IOPS figure out of the storage that you're planning to use. So no more the marketing team say you're going to get 1 billion IOPS from this thing. You could actually take it into the lab, prove it, and you're going to get a value from that storage configured in the way that you want to use it, and you can then take those values forward into your design. So not only does it reduce risk, it means that you can be more precise about the amount of hardware that you need. So it's quite handy. You tend to find that this is where you uncover a huge number of issues as well. So if you're doing Jetstress testing in the lab at this part during the plan phase, you can uncover a huge amount of stuff. Many of my customers have been in this phase for about 3 months or so, and uncovered tons of bugs and issues with the storage stuff that they were testing. And they'd already got that storage in production for other workloads. But because we're now using it with Exchange, and because Exchange, as we all know, is very special, and it makes use of storage in strange ways sometimes, it allows us to kind of pick up on these things and fix them before we go to the next phase. And then the one that everybody is kind of most aware of, I guess, is when you are putting Exchange servers into production, we should Jetstress test them again for very different reasons. The first part of this is validating the design. We're maybe comparing different types of storage. We're trying to see which one we might want to choose and how it behaves. The second one of these in the build phase, we're checking to see that we deployed something and it's behaving the way we expected it to. It's not malfunctioning. It's not got some, dodgy capacitors on the board. It's not we had, when we did the NHS Mail platform, we had a load of disks that were delivered for that ended up being sitting around for a while, and we had a huge number of failures of that when we started to do the init testing. So, there are many cases where Jetstress will save you. Now, you will get into positions in both of these phases where Jetstress is seen as holding up the project, or you get the classic Jetstress has failed. Theoretically, Jetstress hasn't failed. The storage has probably failed. But you need to be prepared and build in when you're scheduling and planning Jetstress in these phases. It may highlight problems that take time to resolve. So, beware of that. And, fundamentally what you're doing here is reducing risk when you go into production. And that's the primary goal of Jetstress. The primary goal has got nothing really to do with storage. What we're doing is we're driving some workload through the disk stack, through the storage subsystem, so that when we finally put users on, we know it's going to behave appropriately. It's much easier to switch Jetstress off or to delay a program by a week than it is to go and throw 20,000 users and tell them, hey, yeah, we're sorry, we're working on the problem. But once you're working on a live system, it takes much longer to resolve. So this is directly from the field guide. The thing, I like to talk about this diagram because the middle bit, this bit, I don't know whether have I got a, how can that work? See that bit here, this square box in the middle, that essentially is easy. So it's the easy DLL. And Jetstress essentially is taking the part of Exchange. So this block on the left here, what this is doing is making calls. It's making API calls into the easy DLL, which is exactly what Exchange does. So if you think about that, what we're doing is we don't have Exchange installed on this server, but what we do have is the easy DLL. And then we have Jetstress, which is the application, and all it does is does the same type of calls to Easy that Exchange does. So what it's doing is it's simulating very precisely the workload that we see from an Exchange server. And there are some nuances in that Jetstress is slightly different, but fundamentally we're calling the same database engine. It's also important to realize that we're using the same perf counters. So we are, when Easy gets instantiated, we register the logical disk perf counters and a few other database counters that we report back on. And this is leading to one of the bugs that we have in the product right now, which I'll talk about towards the end. But if anyone's Jetstress testing right now, it's something you need to be aware of. So there are two types of tests. I'm campaigning and have been campaigning for what seems like forever to get one of them canned. The one that I like to use is what's called the disk subsystem throughput test. Now, both of these test types are essentially exactly the same. They do exactly the same thing on the disk. The difference is in the UI that you're presented with. A disk subsystem throughput test essentially asks you how many databases you want and where you want the databases to be. And it will then decide for you how large those databases should be, and it will base it on 80% of the capacity. So it will fill up 80% of the volumes. So if you say, for example, you've got one volume and you put two databases on it, it will make, essentially, those two databases will take up 40% of the disk space each, and you'll be left with 20% free. Dead simple, right? Really, really simple. It's very hard to screw that up, although people have. But it's quite tricky. And then you control the workload by the thread count. So there's a thread count in Jetstress. The higher the thread count, the more workload. It's like the accelerator pedal, right? The gas pedal. The higher the value, the more IOPS it's going to try and drive through the server. And this is the second test. Now, this is the test that everybody chooses to use when they haven't read any of the documentation. And fundamentally, what this test does is this is exactly the same stuff, but it asks you for the quantity of mailboxes and the number of IOPS for each one that you want to test, and the quota size. And then it kind of multiplies things together and figures out how large the databases should be. If you make an error here, you can end up with a database that is too small. If your database is too small, then the storage may perform better than it should. And we have seen a number of cases over the years where somebody has run this test and put the wrong values in. The databases ended up being too small. The storage passed when it should have failed. When the production users were actually put on this platform, we had perf issues. Customers really confused. I've got a Jetstress test. You told me it would all be great. You know, we did exactly what you said. And when we went back and looked at the Jetstress test, the databases were tiny, because they'd made a mistake when they configured the quota sizes. It's also tempting here for people to put the wrong... What they'll do is they'll start Jetstress and realize it takes a little while to initialize the databases. So they think, oh, hang on a minute. If I use a smaller quota size, it's going to prep the databases much quicker, and I can go to the pub earlier, and that's great. So they end up doing that kind of stuff, and that leads to problems as well. So a recommendation from it, there are cases where you don't have to do this way, or people that choose not to, but fundamentally, the disk subsystem throughput test is the way to do it. There's a percentage option in here as well. So if you're testing on a platform that is over-provisioned, so they've given you a 10 terabyte volume and you only need 2 terabytes, and the databases are going to be 1 terabyte, for example, if you just run this test, it will give you an 8 terabyte volume. It will fill up the whole thing to 80%. But there's a percentage counter, so you can shrink that and control it if you need to do. But fundamentally, our recommendation from experience in the field is that you should be testing your storage at 80% capacity, because inevitably at some point, you will end up with a middle manager looking at you saying, we've got all this spare capacity. And I know that we said we weren't going to use it, but it's doing nothing. Let's give everybody a 50 gig mailbox or whatever and so, our experience is that although the project may have the best intentions of not using that capacity, at some point it's probably going to get used, and that will lead to support calls. So disk subsystem throughput test at 80%. And there are two types of test mode. And again, these are quite curious because you don't really have a great deal of control over these. These are driven from the duration of the test. And this is to do with the background of Jetstress. We have what's called a strict test. or in the code it says strict. And fundamentally that's called a performance test. And that is for what we call short duration. So this is the 2-hour test that we like to run to prove that the storage is performing appropriately. And it's governed by the same latency values and counters that we recommend for the product. So this 20 milliseconds read latency and this 10 milliseconds average log write latency. There are interesting things here that we don't check for. One of them is database write latency. We just don't care. Database writes are quite lazy. An Exchange will just kind of sit there and, it's not really going to be too concerned. And actually, if we're slow writing to the database, do you think that's going to impact the end user? Because we write to the logs, right? We write to the log buffer, essentially. And once Exchange has got that and written it down to the transaction log, we're kind of, we're fairly good, right? It's from a client perspective, it's not going to hold us up a great deal. Read latency, on the other hand, is a big deal. If I'm not reading data from the disk quickly enough, Outlook is requesting data pops up and the phone call rings, right? The phone starts to ring. So read latency is what we're very, very concerned about. And then the big difference between the two tests is in this number of spikes, these 6 spikes. Because when we're testing storage, you will see occasional spikes. You'll see these, it will look like a flat trace, and then all of a sudden you'll get like an odd spike. And that's fairly normal, right? But we don't want to see too many of them. So Jetstress allows you to have 6 of those in a 6-hour test. When we run to the lenient mode, which is the stress test, this is the one where at the moment we recommend a 24-hour test. During that 24-hour test, we're looking for the same latency value, so we're still looking for this 20 millisecond for database reads. But we are a little bit more tolerant on the number of spikes that we'll accept during the test. So obviously, if you get a large number of read latency spikes over 200 milliseconds, that's probably going to shift the average anyway. So if you get a large number, you may fail. But fundamentally, we still allow 6 spikes, but we allow them to be 200 milliseconds. If we see a spike over 200 milliseconds, then we'll fail. If we see spikes up to 200 and there are less than 6 of them, then we'll pass the test. And essentially, it's just a way of dealing with the fact that storage can sometimes be, a little bit intermittent in the way it performs. And Exchange tolerates that really nicely. We're 64-bit. We have a huge amount of cache. We can deal with slight oddities here and there. What we can't deal with is prolonged slow performance from our storage. Failure mode. This is really interesting, actually. This came from a discussion that I had with Boris Lokvitsi. And Boris and I were talking about how we should design for failure, right? So how can you architect your solution design to accommodate and be aware of failure types that may occur? And so we tend to think about this from a server perspective, and it's quite common for project teams and design teams to think about, well, okay, if server A fails, I'm going to move over to server B, right? And it's kind of standard HA model. From a storage perspective, we still think about this, and you'll hear terms like no single point of failure, right? And if you work, is anyone from IBM here? A lot of IBM people? No. So IBM if you work with XIV storage, one of my customers has 12 paths to every disk. Every single LUN that is on their server, they have 12 paths to it. That's a lot, right? Especially considering from an Exchange perspective, we've got 4 copies, right? We really don't care. We don't care if it goes offline. But they do it anyway. And from a storage perspective, quite often this stuff happens underneath. It's kind of quite complex technology, and you're told that it will just work, right? Failover. If you've got multiple disk controllers, multiple RAID controllers, RAID is a good example. The idea is that we'll tolerate failure, a component failure. A component fails, and we will just switch over to the other thing that has failed. The common failure scenario is things like, RAID is a really good example. So let's say you've got a RAID 5 array. You've designed it, and you've run your Jetstress test on it, and Jetstress has passed, and you're all good. The thing is, disks fail quite frequently, right? We've got a reasonable predictive algorithm to tell us how often disks will fail, and the answer is they fail quite often, right? Anyone who's worked in a data center changing disks, there's quite a lot of disk failures. And that means that your RAID 5 array is going to be in degraded mode at some point with workload on it. So how is it going to behave? So, okay, it's passed the test at 20 milliseconds when it's all good. What about when it's in rebuild mode? Will it still pass? And what is the impact to the end users in that scenario? If you have multiple storage controllers and one of those goes down and it flicks from A to B, what's the impact? If that happens mid-test, if that happens at peak time, I don't know, like 1 p.m., 2 p.m. during the daytime, is Exchange going to stay running? What is going to happen to that? And that's what failure mode testing is about. It's things like single spindle failures, multipath, dual controllers, essentially anything that that system is intending to or should continue to keep running if it fails. Then ideally what you should have is a 2-hour Jetstress test with at the 1 hour mark that failure is induced, whether that's a spindle failure, controller failure, whatever it may be. Now, you have to be a little bit sympathetic here. So if you're yanking the back of the power of a controller, you will probably see a disk spike that will cause Jetstress to fail. However, when you go back and look at the BLG logs to say why did it fail, the perf traces, when you look at that, if you see that one single spike and it lasts for 10 seconds and then Exchange kind of carries on running again, you know what? That's probably good enough, right? It's a rare occurrence. It's not something you would do, routine maintenance, and actually the system behaved pretty well. So you have to use a little bit of common sense in here. Just the fact that the test result has said failed because there's been a big spike, it's not necessarily a reason. But you need to go and look at those. You may need to go and look at those BLG files. Fundamentally, we think the test should pass, but you need to have your real-world common sense hat on, and the test report may actually still say, failed on it, but you need to determine why it said failed. So the test process, and again, this still confuses people. Jetstress does not need Exchange. Jetstress is run essentially at the point just before you're going to install Exchange. So as you're looking for your project plan, when you should do Jetstress and when you should run the tests, basically the next thing that comes after Jetstress is running Exchange setup, right? So this should be running when the servers are fully built, fully configured, fully patched. Antivirus should be installed. If you've got it, right, if you're stupid enough to put AV on your Exchange servers, it needs to be running while you're doing this test. You also need to watch the exclusions here as well. So Jetstress paths and the names for the databases are different than production Exchange. So if you've configured exclusions based on the paths that you're going to use in production, you need to be very well aware what you're doing here with AV and making sure the exclusions are in place. So we use the same versions of Easy as we're going to use in production. We install Jetstress and we configure the XML. There's a GUI, we launch it, and we tell it where the databases are going to be. If you have many Exchange servers to test, you can save this XML and then use the command line version on the other servers once you've done that. We then do initialization. And fundamentally, what Jetstress does here is it creates one database. And again, people are often confused here when Jetstress in it takes a long time. It can take a long, long time. And certain storage responds very, very poorly to this, and it just takes a long, long time to put the data in place. But the way Jetstress works is it creates one database of the right size, and then it does a parallel copy, a parallel unbuffered copy of that to all of the other locations. You cannot do this any quicker than Jetstress does it. People have tried, wasted a huge amount of time, corrupted the data, put it in the wrong place, leave Jetstress to do this. If it's taking a long time, I mean a very long time, then potentially there's something wrong with the storage, and go and look at that. But Jetstress does this very, very quickly. Then we run the test. So we do the thread count setting. So I'll say nice things about Alex Costa and bad things about Alex Costa. Alex Costa is the guy that does most of the dev for Jetstress. And he's super clever, absolutely brilliant guy. Alex thinks the thread count in Jetstress makes sense, right? Because it does in code. But people try and equate this to threads in Exchange. They want to see some kind of relationship between this thread value and whatever the value is in Exchange. You start to think about it as, Exchange is having threads or it's doing things. And they're not. They are completely different. Essentially, this is a quantity of workload in Jetstress. and that's it. It has no correlation to Exchange at all. You can, whatever you set the thread count to need to be in Jetstress is very specific to Jetstress. It's got no relationship to Exchange. But fundamentally, as you increase thread count, the workload increases. So what we do is the way I do this, a 20-minute or 30-minute test. Start with thread equals 1, run the test, look and see what my IOPS value is. Is it high enough? No. Thread equals 2. Is it high enough? No. Thread equals 3. Is it high enough? No. Thread equals 4. And then I keep going. And I'll sometimes, if I'm a long way off, if I want to hit a test of 2,000 IOPS and thread equals 1 gets me 60, I may bump it up to 20 or something. But fundamentally it's about finding that point to set the thread count to be. And we want to be close to the limit. So we want to kind of increase that until we just get to the point where the test starts to fail. And that's telling us where the headroom is, where the limit is. Once we've got our thread count set, we then run a 2-hour test. So this is the performance test, the kind of the low limit for spikes. Then we run a 24-hour test. This is proving the stability and the stability of the platform, and this is the lenient test. You don't have to do anything. If you just set the time to 2 hours, it will run the strict test. Then if you set the 24, it will run the lenient test. Once we've done that, we've proven that the storage is performing and stable to meet the requirements that we've got. Well, we're happy bunnies at that point, and we think, this is pretty good. Our storage is behaving, and it's doing what it's supposed to do. And then we start to, kick it, rattle it. If anybody went through Ranger, Greg Taylor started shouting at storage at one point to see if vibration impacted it. But even Greg couldn't shout loud enough to upset the mighty HP storage that we had in the lab at the time. But you essentially, this degraded mode stuff, you're trying to kick it and rattle it and pull cables out and just try and simulate some common scenarios. And then we start to evaluate the results and see, well, okay, have we passed? Have we not passed? Does everybody know how you figure out, so where is the value that you figure out what your peak IOPS should be? How do you get that value? Does anyone want to offer a solution? How do you know whether your test has got the right number of IOPS? Yeah? Bang on, sir. I wish I could give a prize away. Do you want this projector? I don't know what that does. You can have the projector. I want to put something under that. Anyway, so we're looking for the value from the storage calc, right? And I'll show you in a little while exactly the value. It's in the field guide. It was amazing. Before we actually sat down and wrote that stuff down, nobody knew what that value should be, right? And I'm not joking. These were people that were, Exchange professionals. You were seeing questions. Do I add the log IOPS and the DB IOPS? Or do I just do the DB IOPS? Or, do I add stuff to it? Do I add 20% to this? People were asking all these questions around where this value came from. And fundamentally, Jetstress, and in fact, storage testing in general, we don't care about log IOPS at all. We're not interested. In fact, we don't even care. In fact, I had a customer 2 weeks ago that raised a case because their Jetstress test passed, but the log IOPS was too low. Right, and it was confusing for them, right? I don't mention it in the field guide. It wasn't something that we really went into, but fundamentally, we don't care. We are not interested in log IOPS from a Jetstress perspective. We're only interested in DB IOPS. So what you're taking is the database IOPS per server from Ross's calc, and then you're looking in the achieved transactional IOPS on the Jetstress test report. And I'll show where the report is later on. But they're the only two values. That's it. Yeah? We'll fail a test for log latency, yeah. Yeah, for log write latency, not read latency. We're not interested in that. But for log write latency, we'll fail the test if we go over 10 milliseconds. And then we go into this cleanup section. So what we do here is remove Jetstress, remove the data, and then we reboot the server. I did write some scripts to do this. I think I talk about this. I think I talk about this in a second anyway. So the idea here is that we're cleaning the server up. We're removing the Jetstress test data. You would not believe the number of cases that I've seen where a customer has put Exchange into production and ran out of storage space a week after they've gone into production because they had not removed their Jetstress test databases. It's quite an easy fix, but it's quite embarrassing for the customer. Yes? Yep. No, leave it. So there are some storage vendors get very touchy here. So a NetApp in the house. Any NetApp boys? Yeah. So the NetApp hardware reacts quite badly to this because the rate of data and the rate of change. So what those guys recommend is that you snapshot the volumes essentially. So you would prep the infrastructure, prep all the databases, get them all done, take some snapshots of those databases, run the test, and then revert back to the snapshot so it's clean and we're not dealing with the background maintenance stuff. So, but check with the vendor. I mean, that kind of stuff changes. It's always worth talking to the storage vendor that you're testing with and just check if they've got any recommendations as you go through this. But the golden rule with all of this, right, is so Jetstress rules. You need the little green tick on the top of the Jetstress test data. But your storage vendor are king here. Your storage vendor are the people that understand how your storage works, and they're the people to resolve the problems that you see here. They'll quite often blame Jetstress, and then they'll come to me, and then I'll tell them it's their fault. But yep, another one. Yeah, so I'll cover that I'll cover that shortly. The active and passive and lagged stuff. It's a good question. None of the rangers asked that. How many rangers are in actually? Is it just you? How many? 2, 3, 4. I'm disappointed. You guys should have asked that question. So the installation, we need Jetstress, and Jetstress needs easy. So these 4 files we need. You can get these from the installation media. The primary recommendation here is take the versions that you're going to use in production. So if you're going to use SP1, use the SP1 files to go and validate. Jetstress treats everything as an active database. It's got no concept of passive or lagged. It doesn't understand it. So essentially what we do when we're testing with Jetstress is, the way I treat this is every single place you may have a database is going to be an active database in Jetstress. And whilst that seems a bit odd, actually, anywhere you've got a secondary database, it could become active, right? If you couldn't put a copy on there, potentially, there may be a scenario where it may be active. So we work on the assumption that if it may become active, then we should validate it, that it can meet the IOPS requirements. There are cases, especially at scale, where you've got lots of copies, that Jetstress essentially overworks things. It's very difficult to be precise with this. So the Jetstress test actually works out being slightly heavier than we need it to be. For most customers, if it's direct attached storage, we don't really see a problem. If it's SAN storage, especially iSCSI stuff or anything where you've got throughput constraints, these can be an issue. But if your storage is that close to the limit, so there's not a big difference, you're like 10, 15% maybe. If you're that close to the limit, you probably shave things a little bit too tight anyway if you're failing to do with that. So as I said before, disk subsystem throughput because it's nice and easy. I'm going to flick through this. Right, so the initialization throughput, it took me a long while to get my head around what was happening here. Because sometimes you'll see init happen really, really quickly, and sometimes init takes forever. And the number, I probably get one phone call a week from somebody saying, it's been initializing for 3 days, and it's still going. Well, what is the deal? The table here comes from my lab. And my lab is extremely exotic. It's got an MSI RAID controller from the 1980s, and it's got 4 1 terabyte disks in it, in RAID 10. And then I prep on that, and they're the values. So I kind of figure that if you base your init timings on that, you'll be in, right? Although that isn't really true. Some storage goes even slower than this. What we're observing, though, is if you do this init on JBOD, so if you've got 20 JBOD spindles, for example, init is extraordinarily quick. Very, very quick indeed. The first part where we create the first database essentially writes to one LUN, so it writes to one spindle. That takes a little while. But then what you end up with is we're reading from 1 and writing to 20, and we're doing that sequentially. So you can see extremely high throughputs. I mean, this was one from a test that Boris did. It was essentially 1 terabyte a second. Very, very quick throughput. Some storage behaves very poorly when you do this. So some of the types of storage, the kind of more advanced and clever the storage is, the worse it handles this kind of dumb copy of files, strangely. You can see, if you observe the first couple of hours of this, it's normally quite linear. So the way I do this is I wait for the first database to be created, and then what I do is I look on a monitor and see what kind of throughput I'm getting at the copy phase. And then you can see, well, OK, I've got X number of databases to copy. I'm copying at X megabytes per second. And you can then go and calculate how long it's going to take. Jetstress won't tell you. It just tells you it's doing stuff. We spoke about this already, really. But the thread count essentially is king. This is how we control the workload. It doesn't have any relationship to Exchange. If you use thread equals 5, you don't have to go and find the thread configuration value in Exchange. It just doesn't matter. This is purely for Jetstress. And for each thread, Jetstress generates roughly 30 random IOPS per thread at 20 milliseconds. So this, again, gets very confusing. If you get a system and you use thread equals 1 and you've got a very large storage array, you might see one thread generate 100 IOPS. And this is to do with the way Jetstress throws a piece of work at the server, and then it waits for a predetermined time, and then it goes back and does some more. But the longer it takes to do the work, the fewer of those pieces of work will get done in a given time. So what you see is if the storage is satisfying those I/O requests really quickly, then you get more of them per minute or more of them per second, so the IOPS value is higher. So if you plot it, then what happens is it curves down like this. So you end up with the initial curve, the initial line is quite steep. So if you have thread equals 1, thread equals 2, it'll almost be linear, and it will rise really quickly. And then as you start to approach that 20 milliseconds latency, each thread will get you slowly steady and let you fewer and fewer IOPS until you breach the 20 milliseconds value. So it takes a little bit of faffing around with, to be honest. The big news from this session is the last time I spoke about this, I was talking about the auto thread count setting and that you can use that now and it was OK. Don't use that. It doesn't work very well. So, yeah, that tells you how good my advice is, I suppose. But the idea being that when we re-architected Jetstress for 2013, we made some changes, and the belief was that the auto thread count would work a lot better. And it did on the lab systems and the tests that we did. There have been a huge number of customers that get really, really confused. The primary one here is if you use the auto thread count and auto thread setting fails, the test can sit there for hours and then just finish and doesn't generate a report. There's nothing. And the customer sits there staring at the screen going, well, Jetstress is broken. It's not working. You know. Yeah.
I had a storage vendor that had cranked up sluggish sessions.
Yeah.
And they also at the same time cranked up thread count.
Mm-hmm.
So what's the recommendation? I mean, is that effectively the same as just lowering the thread using your?
Yeah. OK. So it's a really good. It's a good question from a range of. Yes. Get in. So we have a couple of ways of controlling IOPS in Jetstress. One is the thread count. The thread count is kind of like the core setting, right? It's the big control of making change. We've then got another setting in the XML file called sluggish sessions. Sluggish sessions takes roughly a third. Each increase in sluggish sessions takes roughly a third off the IOPS per thread, give or take. And each thread that increases obviously doubles the workload from the thread count before. It doesn't really matter whether you have high thread count, high sluggish sessions, low thread, low sluggish, I can't even say it, but whatever. It doesn't really matter how you achieve the IOPS value that you need in Jetstress, as long as you do it somehow with the dials. Typically, the way I do it is with thread count. So I'll get thread count as close as I can. And actually it's less of a problem in 2013 because one thread spreads across all of the databases. Whereas in 2010 it was really tricky because each thread was per database. So if you had 20 databases, one thread could make a difference of like 1,000 IOPS. It could make a huge difference. Whereas in 2013 it isn't. It's far more granular and is easier to manage. But fundamentally, you get as close as you can. If you can't get the values that you can't quite get to where you need to be, then that's when you muck around with sluggish sessions. So what I tend to do is get the value to just fail the test. So I'll get my thread count just high enough, and then I'll drop sluggish sessions up 1 to bring the test results down. So it is a bit, it's a bit like juggling, really. You're mucking around with those values. We do a 2-hour test, a 24-hour test, and then we do our degraded mode test, as we've already spoken about. The degraded mode test is where the arguing starts normally. So most storage these days and most storage vendors have got a really good handle on Exchange and will come up with solutions that will pass this stuff pretty quickly. If you've made a very poor choice in your storage, you will never get Exchange to pass the degraded mode test. There are certain types of storage out there, and if you come and see me in the pub later, I will tell you. But there are some types of storage out there that will never, ever pass this test, and we just can't get them to pass, and the storage vendor can't get them to pass either. So this is why it's important to work with your storage vendor. I'm not telling you. Yeah. So, it's important to work with your storage vendor and make them aware what you're doing with the storage. Don't work in isolation, right? Go and talk to your storage vendor. Hey, we're going to use this. We're going to put Exchange on it. We're going to run Jetstress on it. Have you got any recommendations for us? This is what we're going to do. Work with them, and hopefully, most of our storage vendors are really cool guys, and they will help you through that. Right. Oh, yeah, I've got a report to show you. I wanted to show you. There's some bits in here that I wanted to... This is very exciting. Where is that? So has everybody seen one of these before? Is this the first time anyone's seen a Jetstress report? A few guys. So it's a bit strange, to be fair. I mean, some of the stuff in here, to be fair, 4 years ago when I started to do this, there's a value in here, which is the most important value, which is this thing here. And I was in the UK, and I went to see all of my colleagues in Premier and asked them what that value was. And how many of them do you think knew what it meant? None. So, and it's what's interesting about that is, it's not very self-explanatory. Do you think that's database and logs, or just database? Doesn't really tell you, does it? If you're an Exchange developer, the key thing is transactional, and that tells you it's part of the database. So it makes sense to them. Doesn't make sense to anybody else. But that's the value. That is how many database IOPS you have achieved in your test. That is probably the only thing that you need to look at in this test in reality. That should be the big thing. You open the storage calc when you look at the number. You look at the... in fact, I should go and get that. I'll see if I can get Ross's calc. So in the server calc, and I think, didn't Brian Day, I will call him Brianna, but didn't Brian do, he's done a calc session. And he did make fun of me as well, so he deserves to be called Brianna. So. On the role requirements tab, if I do... It is this cell. So in this case, we want 10 IOPS. Which doesn't seem very many, but, Oh, what am I doing? Yeah, okay, all right, fair enough. Right, so but that's the cell we're interested in, right? So we want essentially that's telling us IOPS per server. Now you'll notice the similarity in language, right? You'll notice that it says, it doesn't say transactional, does it? It says database on there, and yeah, there's no way you're going to guess that those two are the two values that you need to compare, right? So we make this really simple. So, complete newbie, it's so easy to do this. But they're the values, right? So it's as simple as that. So you take the calculator, you fill your stuff in, and it will tell you that you need 1,005 IOPS. You can see where people get confused here because we put the log IOPS underneath it, and people say, well, should I combine them together because they're still kind of IO, and so... But that's it. We just take in that one cell for the server, and then we are comparing that against this value here. Fundamentally, if this says pass, and this value is higher than the one in the calc, you are done. You're out of there, you're done, you're happy. Do your degraded mode tests, As long as you've got the little green pass at the top and you're still hitting the values, you're good to go. Go to the pub, go home. You're finished. If it doesn't, then essentially the report will show you some things, but the report's not that great, to be honest, at telling you what the problem is. There's a couple of caveats to that, though, and one of them is down here. So this table, the transactional I/O performance, this is showing us the values of the database. So this is the database without dbScan running. So this is purely the I/O for the databases themselves. It tells us the latency, it tells us how many reads per second, and blah, blah, blah. The interesting one is this latency counter, so we can see what they're doing. This table is one that is pretty useful. So this is BDM, the background database maintenance statistics. Now, this is really interesting, and in fact, I was talking to Matt Gossage about this a few weeks ago. Back in 2010, we first introduced background database maintenance, right? Now, essentially, it's a sequential read. It is a sequential read of the data in the database, and it reads every page, and there's a CRC check to validate that the data is as it was when we wrote it. So it's essentially, it was to stop this concept of bit rot, as they used to call it, where I don't know, disks rot apparently, but it was to do with stopping, corruption essentially on the disks caused by the storage, a failed write, or maybe the disk failing over time. And that's a good thing. Now, the problem with that is it's sequential I/O, and it was on a per database basis, and it ran constantly, and it was a fixed throughput. So the more databases you had, the more I/O you had from dbScan. And that caught a huge number of storage vendors off guard with 2010, because they would still design based on IOPS, and then they would run their Jetstress test, and it would fail. And they would say, "But hey, hang on a minute, right? We've got way more spindles than we need for the IOPS target." But what we saw was happening in frequently in these cases, you would have the discussion where customer wasn't happy running large databases. We could have 2 terabyte databases, and the customer said, "Well, I'm not really very happy with that. That's a large database, and I've got to back it up and do a ton of stuff. I want 200 gig databases like we had before, but I'm going to have 10 times more of them." And each one of those databases brought with it the dbScan stuff. So this throughput, the I/O throughput, went through the roof. Because of that, you saw the disk controllers just get flat out. And the Jetstress test would fail essentially not because the disk spindles were too busy, but because the disk controllers, the CPU, was flat out dealing with the throughput. Now, why is this table important, and why did I go through that kind of stuff? The reason I went through that is you see this value 8. That's telling me that there were 8 BDM, or I'll call it dbScan because that's how the PG refer to it, but it's essentially this background database maintenance. Each one of those is 256 kilobytes, right? So if I bring up my, I've got a degree in maths, but I can't add up to save my life. So if I do 8 times 256, 2. So what you can see from here is this test, BDM was running at 2 megabytes per second. Right? I know that each BDM request is a fixed 256 kilobytes in size, and I know that I was doing 8.1 requests per second. So I know that it was running at 2 megabytes per second. What does it say in the calc? Does anyone know? It says 1. 2013, it says 1. It's wrong. It's 2. It's always 2. The same thing happened with 2010. They said it was 5, and it wasn't 5. It was 10. But the calc got changed to 8, I think, or 7.5, something like that. So it was wrong then. But it's quite a low. 2 is actually quite low, and we're not seeing any issues from that. But I am going to work with Ross to try and get that changed. Now, why is this useful? Well, let's say, for example, now that it's going to run at 2. This system is fine. This is a great test report. As you'd expect from Boris, I think he threatened to have his customer murdered if he didn't do what he told them. But they got a good test. They had a good test report, and they're all happy. And it should be 8. But if you look at a 2013 test result and that value is down at 6 or 7, it's highlighting to you that the storage is incapable of keeping up with the throughput. Right? The DB latency stuff will tell you you're not getting enough IOPS through. If this value is too low, look at the disk controllers and start checking things out at that perspective. You see this frequently on things like iSCSI or if Some of the NetApp stuff will struggle with this as well. Anything that struggles with sequential throughput, it can be quite problematic. But this is the table that helps you understand that's the root cause, and you can go and take a look at that. Typically, what we've seen in the past, where this throughput is a problem, storage teams can take a little while to figure it out because they're concentrating on the IOPS and the spindle and the disk response times and analyzing that side of the storage, and not really concentrating, because it's quite unusual to see a storage array throughput bound. Right, so that's that bit. Oh yeah, so I'll ignore that. Total I/O performance table is the database IOPS plus BDM, so you can see how that's responding as well. And then also this thing at the bottom, it's always worth having a scan through this. You will see at the bottom you'll get this kind of thing. And it will start to tell you, if the test has failed, it will try and tell you why. So if you failed because of, I don't know, like a lost flush or something catastrophic, so fundamentally the storage has, it's misbehaved, or Windows has something's gone wrong as we're doing I/O. 9 times out of 10, it will appear in this table. Now, it doesn't show in here as well in this particular report, but the 2013 version of Jetstress will have another table. And if you have I/O errors, what we call soft errors, so essentially something that we could fix via page patching. So we'd maybe try and read and write from a block on a disk, and it fails. What we do then is we do another commit. So we try and write the data to the disk. It doesn't do what we want it to do. We try again. The disk will remap it and stick it somewhere else, but it still counts as an I/O error. Now, back in 2010, we would have just failed a test at that point, and the thing would have keeled over. And we figured that was a bad behavior, because actually in production, Exchange will just fix that with page patching, right? We will just kind of figure, that block is a bit screwed, right? We'll just kind of try and rewrite that again, or we'll request that page from somewhere else and we'll fix it that way. So Jetstress deals with that a little bit better. It's essentially to deal with the kind of soft failures of JBOD spindles a little bit better. We did that. So the success criteria, this is another one of my project slides that I deliver to project managers when they're struggling to understand what success means. We need to complete a test run without error or corruption, right? So we need to meet the perf targets, and we'll talk about those in a sec. But fundamentally, the test has to run without destroying the data, right? It has to run through without causing corruption. We must meet or exceed the latency recommendations, whatever they may be. Currently, that's still 20 milliseconds, and those spikes, the values for spikes. And we must meet or exceed the IOPS values that we've determined in Ross's calc. We need to do that for a 2-hour test, for our 24-hour test, and a degraded mode test. And you can see I use colors and large blocks to make it easy for project. Are there any project managers in before I offend any more project managers? But large color blocks to make project managers understand and be happy with that. When we clean up in the field guide, I added these scripts. So there's create Jetstress data folders and remove Jetstress data folders. Essentially, what these PowerShell scripts do is they parse the Jetstress XML file, and we'll go and clean up the data for you, or create the folders for you if you need to. So these are quite handy if you're trying to automate things, or if you've got a lot of Exchange servers and you just need to clean things up afterwards. So essentially, you run the PowerShell script, give it the path to your Jetstress XML file that you've used to run the test, and the PowerShell script will go and clean up all of that data and folders for you, so that you've got a nice clean volume to run the test on. So let me flick through some of these. So these are the changes that we've got in 2013. We capture the event log. We log errors against the volume. That's this separate table. So if you get I/O errors, it will say volume 1, and it will tell you that we had read errors or write errors or whatever they were. If we get an I/O error that's not a soft failure, we'll fail the test. Now this line, the 1018, 1019, 1022, these, we start to detect these now rather than just fail. So previously, we didn't do a very good job of picking these up. Detecting DB time too new and DB time too old is really important for lost flush detection. So for those people that don't know, a lost flush is kind of really insidious. It's the kind of worst type of storage error that we can see. Essentially, that means we've written some data, or Exchange believes it's written some data, and what ended up on the disk is not what we thought we wrote. Now that gives us a lot of problems in a mechanism where we're replicating data around, because that could happen on the passive copy and not on the active copy, and we just wouldn't know that had occurred until we came back to reread it. And once you've got that, those databases are diverged now. They're not the same. So these can lead to huge problems for us. So Jetstress now detects that better. You can see there, auto-tuning should work again. This was the slide that I used last time. I've put a star next to it this time. It might work, but to be frank, you're probably better off just trying to set the thread count manually. It saves you a bit of time, and just do it yourself. The big disappointing thing for me was that you cannot now use Jetstress 2013 with Exchange 2010. So if you're testing Exchange 2010, you need to use Jetstress 2010 with the 2010 Easy DLL. You should only use Jetstress 2013 against Exchange 2013. Fundamentally, the reasons behind this were testing. The testing timeframe wasn't enough for us to do it back with 2010, and they couldn't take the hit for resource to go and re-engineer it to work with 2010. Basically, the process and the UI. Has anyone used Jetstress 2013 yet? Has anybody using the testing? Yeah, so a few people are. So it looks exactly the same as 2010. The UI is just as crap as it always was. It has not really changed a great deal. It's still pretty sucky. And to be frank, we did talk about canning the UI and getting rid of it entirely and rewriting one. So essentially having the field writing something in C# or something that made it a bit better, or even Power GUI would be better than what we have. But we kept it the same. So there's a couple of known issues that we've got. If back when we had CU1, we had an issue where if you tried to Jetstress more than 38 dBs, we would just fail with this absolutely beautiful error message, completely nondescript. This was to do with a memory error that got it. Which essentially was to do with a code change that was checked into CU1 that broke the way we did dynamic memory. And the way Jetstress works differently than Exchange in the way it actually instantiates easy, and it got tripped up by this change. So if you are back when if people were running CU1 and deploying CU1, the fix was to validate and run against the RTM DLL, or I guess now, I mean, why you would be running against CU1, I've no idea, but then to just essentially use a different easy DLL than CU1. This is the current issue that we're enjoying. And this goes back quite a long time, actually. So this is the problem with faulty logical discounters. When you mount a disk volume, Windows creates some logical discounters for you with the name of the volume. And if anyone's deployed a 2013 DAG with auto reseed, one of the things that you will now enjoy is that we mount most of the volumes twice with two names. However, there are not two logical disk counters for them. There is one, the first one that you mounted. And this causes us a problem, because the scripts that are provided in Ross's calc mount the volume first and then the dB. And then when you come to do your Jetstress testing and it asks you which path would you like to put your database in, you select the database path because that makes most sense. And then you start Jetstress, and Jetstress gives you this gorgeous error and tells you there's a problem with your logical performance counters. And you go and look in perfmon, and you can see the perf counters, but you don't see databases, you'll see volumes. But you think, well, if this is there, why can it not find it? Now, the fix for this is twofold. So we have, Alex has checked in a fix in Jetstress, which is worming its way out of the behemoth that is Exchange at the moment. So that will be out in weeks, months, maybe. I don't know. It's on its way out anyway. The second fix for this is a change in the scripts that we use from the storage calc. So Ross is currently working. There's a few other changes that we've checked in, and the next version of the storage calc will have these fixed. So essentially, it mounts the database volume first, and then the volume. So the perf counters are there. There is another session on Wednesday with a colleague of mine. Yeah. So we have a great session, and this is all about. Do you want to pitch your session? The store port tracing. Yeah. So this is what. So Alessandro is going to talk about the stuff when it gets really tricky and it's broken, and everyone's sitting around the table, pointing at each other. That's the session to go to figure out how to make sense of that and actually what is to blame and how to fix it. So, there's a lot of stuff we can do without going that deep. But to be frank, sometimes you have to get down at that point. So I've had a few customers that have been in that situation for a prolonged period of time, and it can be quite tricky to determine where the problems are. So, and those skills are not very well known. They're not part of the community. You don't see, there are very few people that actually know how to do that. So I would urge you, if you're in the field and you're working with Exchange storage a lot and doing Jetstress a lot, then that is a great session to go to. It will really, really improve your skills to help you understand and determine root cause analysis of Jetstress failure. So with that, I'm going to go on to Q&A. I can see people are eagerly wanting to ask me difficult questions. Do you want to get on with your question? Is it easy?
I've actually just thought of another one as well. So
Two?
Multi-host mode.
Multi-host mode, yeah. So fundamentally, multi-host mode is, I could do with a big whiteboard really, but all multi-host mode does is inject a pause after the database test. So the way Jetstress runs is it runs the database test, and then it runs this CRC check at the end, what we call the checksum mode, to check the databases are not corrupt. And that's great, right? It's brilliant. If you're using direct attached storage, that is absolutely fabulous, and it works great, right? It's really great thing, and it runs the test, and then it runs the CRC checksum and proves the database is okay. Imagine the scenario where you're testing against a SAN. You've got your, 4 servers. They're all connected over a SAN, and you run your test. Then what can happen is you start server 1, then you move over and start server 2, then you move over and start server 3, move over and start server 4. You run these in parallel. And one of two things will happen. A, there's a bit of a gap between you starting them, and server 1 starts doing its checksum before the others are finished. And the problem with the checksum is it's sequential, right? So it's quite easy for the disks to deal with, but it throws a huge amount of throughput. So 300 megabytes per second is quite normal to see during the checksum phase. And that works the storage really hard. So we can see it skews the test. So you've got one server running the checksum, one server running the database test, and it essentially makes the other servers fail because it's pressing on. The other thing it will do is if you end up with the servers, and let's say you've managed to start them all pretty quickly, and they've all finished their test, and then they all switch over and start doing the checksums at the same time, that's when the storage administrator rings you and says, what are you doing to my storage? You know, the thing's on fire, it's all going crazy, because the workload that the checksum part adds to the storage is incredibly heavy. So multi-host mode essentially just adds a delay. So it asks you to press a button, and that's all there's to it. And it just allows you control over when the checksum runs or not. Personally, I tend to switch the checksum mode off. If I'm in that scenario, I'll quite often switch it off while I'm setting the thread count and setting up the infrastructure, and then I'll just run one test with everything in play. So, does that answer the question? Another question?
Did you fix, so with Jetstress 2010,
Yeah.
there was the undocumented feature with stress mode that you should run online?
Yes, that's fixed. Yeah, so that was fixed in 2010 as well. So there was a bug in 2010 where you ran... it was when you ran over a 6-hour test, it was still running in stress mode and not running in lenient mode. So it was essentially running the wrong test if you did it via the GUI, I think. Which was the GUI that was broken or the if you ran it via the command line, it was fine. But that was fixed. I think that was fixed in 2010 actually. That was resolved. So. Any more questions? Yeah?
Yeah, so when you have two DAGs that stretch across sites,
Yeah.
you want to run Jetstress on all the DAG members of one as well as members of the DAG on the other if they share a storage.
Yeah. Exactly. I mean, we don't really care which site they're in. We just care about which storage they're sharing, fundamentally. You know, so the diagram that I typically draw is I'll draw out the storage islands, and then you draw out the nodes, and then you draw them. And I don't draw the AD sites as part of that. I'm just interested in, you know, which storage. And actually, it's not just the storage chassis. It's the fabric as well. So, you know, if I've got 5 servers sharing 5 SAN chassis, but they're on one fabric, then we want them all running at the same time just to prove that the workload can be managed. So.
Cool. So, and then the other thing I heard for takeaway was you don't have to reinitialize the databases unless the storage vendor says you need to.
Yeah, exactly. And most of them have got good guidance for that now. So NetApp, Rob Quimby wrote a paper for NetApp which talks about Jetstress testing specifically and what you should do. So it's got some recommendations around how to configure your NetApp storage for your Jetstress test and some scenarios around using snapshots to improve the maintenance hit when they're reallocating blocks and stuff. So, but most of the vendors have got, if they need it. I mean, what you typically find is the simpler the storage, the less guidance you need, right? The more exotic it becomes, the more you need a bit of guidance for that. But
NetApp basically tell
easy.
hang on, tell it how it is. Basically, NetApp, so I'm doing Jetstress now as a company. So I've got something similar to what you've got. I've got two different data centers, and I'm running multi-host mode in one, same in the other. They don't share any package, but NetApp had to come in and make sure the way I set the disk up, make sure I set all the settings right. So there's a couple of settings they want me to turn on in Jetstress, turn back on publish. Just a couple of things there, but also, as Neil said, they want a snapshot once you've done the create, and once you've done a Jetstress, you can restore the snapshot because there was a file system on GB pages in the databases, so it's not actually good for their work. So, but it's the second time I've run it, and I'll check it tomorrow.
Yeah, so degraded mode is problematic on that infrastructure as well. So
They won't let me do that.
yeah, because it won't pass. Shit, I said that, didn't I? I said shit. But work with a storage vendor basically and see what they've got advice. So NetApp have got Rob Quimby. So he's the guy. If you do NetApp stuff, Rob Quimby is the guy to talk to, and he'll help you figure out how to get your storage to a point where it's ready for production. So
On a side note,
yeah.
I've done comparison between JBOD and actually a dedicated EMC carrier. JBOD actually
Yeah, JBOD strangely. I mean, if you think about JBOD, I mean, you're from an IOPS perspective. I mean, it's just so simple, and you've just got the disk spindles. Yeah, it's there are some problems. I mean, there are some issues, and we see it in the service where if you've got a RAID controller, the RAID controller does a lot more for you than just do RAID, right? It kind of massages the responses back from the disk. So if the disk starts to misbehave, disks typically don't fail. Like, I guess. So the way the service team explained it to me is a bit like dropping dead, right? Is that some people just keel over and drop down dead, right? Most people kind of spiral out of control and fail, get more and more ill and more. And disks do the same thing, right? And once the disk is getting a bit ill, it might not respond the way the standard says so. And your RAID controller does a good job of hiding that from the operating system. Windows kind of sucks with that. Doesn't deal with long disk timeouts very well. Doesn't deal with storage not performing and not behaving the way it should do. And we can see some odd behaviors, right? So we see things like Windows will start resetting the SCSI bus everywhere because of one disk. We've got one disk, it's failing, it's kind of a little bit unhappy, it's a bit sick, right? And Windows can't talk to it, so it'll try and reset that LUN. And it'll try and reset that LUN again. And then after a while, it kind of goes, I'm going to reset everything now. So all of the active workload that's all happy and running absolutely great, all of a sudden Windows just resets the whole SCSI bus, right? And Exchange is kind of going, whoa, where's my storage gone? And then tries to figure it out. That behavior is changing, and the Exchange team are trying to deal with that, and we detect more of those kind of I/O problems in flight. Store is more intelligent. MA, managed availability, will take action if we start to see disks that are performing a bit poorly and we've got another healthy copy. We'll kill the server and blue screen and move it across somewhere else to avoid that kind of stuff. But JBOD, from a performance perspective, is great. But it's got some intrinsic issues that we used to be protected from with RAID controllers, and now we're relying on store and managed availability to protect us from. So, there's no such thing as a free lunch, right? It's cheaper, the performance is great, but there are some downsides to it as well. And if you know what they are, then you can take the benefit of that, which is what Exchange have done with store and MA. But you need to be aware of how that behaves. Any more wonderful storage questions? No.
What's your preference on storage vendors?
Oh, God. I don't know. So, do you know what? Over the years, I've fallen out with all of them, but most of them now I've got a pretty good handle on Exchange storage. You know, there's not really good and bad. I mean, my advice is use the simplest you can do. So, and I can tell you that the majority of the most successful deployments I see right now are using disks in chassis in the server. So things like the DL380, for example, with 12 or 14 disks. So essentially putting those 4 terabyte large form factor disks and putting them in the chassis and using JBOD. So there's no RAID controller in play. There's no storage chassis in play. There's no cables. It's all just done in the chassis. And it can be defined as a single SKU deployed into the data center, and then everything can be scripted and automated. It's those kind of things. It's the simplicity that works the best. And but you can't always do that. So there are cases where that just isn't viable. And I guess it's just start simple and complicate where you absolutely have to. But that's kind of what it is. Think cheap is where we're at. The product Exchange is a product now being run and driven by the Exchange product group, or essentially a business now. 365 is a business to them, and the cheaper they can run it and cheaper they can operate it, more profit they make from it. And make no mistake, that's driving the shape of Exchange, and especially storage. So the decisions we're taking in storage and the testing that we do is around making Exchange work in the service on those cheap disks that we know we're going to have to use to make the service viable. So, I guess avoid anything complicated. If you can't explain to your grandparents how that storage works, it's too complicated. That's my advice, without naming vendors, right? And no, you don't need solid state. I'll go with that as well. That's a freebie. You don't need that. Any more questions? Oh, class dismissed, I guess. What time are we supposed to finish? 1:15. Class dismissed then. Well, free to go. Thank you all for coming. Thank you.